we see this glow of light, but usually around comets, the glow is produced by dust.
Something truly strange has just occurred on Mars. One of NASA's rovers captured a series of mysterious images showing an interstellar object known as 3I/ATLAS that behaves unlike anything ever observed before. It neither moves, shines, nor reflects light in any familiar way. Then, for 3 full hours, it completely vanished from every telescope in the solar system, only to reappear later, moving twice as fast. What exactly did the rover record out there? Let's find out.
It may release some other objects that reach the planets, and it will continue along its course.
Secrets buried in Martian dust. Engineers at NASA's Jet Propulsion Laboratory were expecting another quiet evening of routine data. The rover Perseverance had just finished its scans of Jezero crater, and the team leaned back, waiting for the last batch of images, which would probably be nothing more than barren rocks, sand ripples, and distant ridges. But when the first image came through, something was wrong. A faint smear sat on the edge of the horizon, too structured to be a glitch, too dim to be a lens flare. It wasn't supposed to be there. What did the rover just capture floating above Mars? Could this be the first ever interstellar object photographed from another planet? And if so, why does it look like it's moving toward us? The frame in question came from Perseverance's NavCam, a navigation camera designed for terrain mapping rather than astrophotography. The raw feed showed the usual Martian plain, dark regolith scattered with pebbles, the blurred outline of a distant dune, and then, just above the horizon line, a tiny blur only a few pixels wide. To the untrained eye, it looked meaningless, almost like a speck of dust stuck to the lens. Mission scientists were used to these anomalies. Cosmic rays, bits of solar interference, or digital noise could all produce similar patterns. So at first, no one gave it much attention. But one data technician noticed something that didn't fit. The position of the blur shifted slightly between consecutive frames, not enough to suggest camera shake, but just enough to indicate motion across the sky. To confirm it, multiple teams began cross-checking. The Mars Reconnaissance Orbiter, circling high above Perseverance, reported an almost undetectable brightness fluctuation along that same region of the Martian sky. The European Trace Gas Orbiter, operating on a different orbit and at a different time of day, registered the same faint glint when its wide-angle imager was run through high-sensitivity filters. Back on Earth, astronomers pulled the latest star tracker data from deep space telescopes and overlaid them on Perseverance's sky model. The match was almost exact, within less than 1/10 of a degree. What began as a random blur in a navigation frame had suddenly become the first visual confirmation of an interstellar object from the surface of another world. Once the correlation was established, NASA's image processing team got to work. They began reprocessing the raw NavCam data, stacking multiple exposures and correcting for atmospheric scattering. The thin Martian air, though dust-filled, allowed more stable imaging than Earth's dense atmosphere. Using algorithms originally designed for exoplanet detection, they de-blurred the pixels, compensating for the rover's subtle lens distortion and phase angle relative to the Sun. Slowly, the image came into focus. What had once appeared as a vague dot now showed elongation, a shape that was not round but stretched, possibly cylindrical, suggesting a multi-kilometer object glinting as it rotated. Each pixel now represented several kilometers in scale, meaning that what Perseverance had captured was enormous, far larger than any known satellite, meteor, or fragment in Martian orbit. To test whether this shape was just an illusion, the engineers applied motion correction to the image series, aligning each frame with stellar reference points. The object's movement revealed a consistent drift, perfectly aligned with 3 I/ATLAS's predicted velocity, nearly twice the speed of typical interstellar debris, moving at tens of kilometers per second relative to Mars. That speed, combined with its distance and apparent luminosity, confirmed that this wasn't a random asteroid. It was an interstellar visitor passing through the inner solar system, and Mars had accidentally caught it on camera. By the time the enhanced image circulated through mission channels, rumors had already started spreading online. Amateur astronomers comparing the rover's data with open-source tracking logs noticed the anomaly before NASA's official statement. Screenshots of the blur, blown up and filtered, began circulating on social media with captions claiming, "Mars just saw an alien ship." The implications were enormous, and so were the questions. How could a rover on Mars detect an object that Earth's telescopes barely managed to track? What if the object's reflected light was stronger than expected, or even artificial in origin? The most advanced laboratory ever sent to another planet had, by sheer chance, documented a cosmic event no one thought possible. A fleeting moment when Mars itself became the witness to something not of its world. And this was only the beginning, because what came next, the data that followed from orbiters and Earth-based observatories, would make that single image seem ordinary in comparison. The truth NASA won't explain. For decades, scientists have dreamed of catching a true interstellar visitor from up close, but until now, every such object had been seen only from Earth. The fact that a rover on Mars, a machine built for geology and soil analysis, accidentally captured a confirmed image of one is nothing short of historic. It reshapes what we thought we knew about both space exploration and our ability to study cosmic intruders. But to understand why this moment matters so much, we need to look back at the very short and very strange history of interstellar objects. How many of these visitors have we ever confirmed? And what makes this one so much more unsettling than the rest? The story begins with one of the most debated discoveries in modern astronomy, the object known as 1I, or Oumuamua, which was first spotted in October 2017. It was the first confirmed interstellar object to ever pass through our solar system, and everything about it defied expectations. Instead of behaving like a typical comet or asteroid, Oumuamua showed no visible tail, reflected light in unpredictable ways, and accelerated slightly as it left the sun's influence, suggesting some unknown form of propulsion or gas release. 2 years later came 2I Borisov, the second known interstellar object discovered by amateur astronomer Gennady Borisov. Unlike Oumuamua, Borisov looked more familiar, an active comet shedding gas and dust, but its hyperbolic orbit confirmed it had come from outside the solar system. These two cases were already rare enough, but in early 2024, a third object appeared, 3I/ATLAS, marking only the third confirmed interstellar visitor in all of recorded history. That makes this discovery extraordinary because catching even one of these objects is a once-in-a-century event. 3I/Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in late February 2024. ATLAS is a network of telescopes in Hawaii and Chile designed to spot incoming near-Earth objects that could pose a collision risk, but this time it picked up something that wasn't on any predicted trajectory. The object's brightness and speed suggested it wasn't gravitationally bound to the Sun. Within hours of its discovery, observatories across the world, from Mauna Kea to the European Southern Observatory, began tracking it, while NASA and the European Space Agency coordinated through the International Asteroid Warning Network to verify its orbit. As the early data came in, one feature immediately stood out: the object's light polarization. In simple terms, polarization refers to the orientation of light waves, which changes depending on the surface that reflects or scatters them. When light bounces off dust or ice, it becomes polarized in predictable ways. Most comets show what's called positive polarization, meaning the light waves align in a particular direction when viewed from specific angles. But 3I/ATLAS showed something almost unheard of. extreme negative polarization. That means the scattered light was actually polarized in the opposite direction to what physics predicts for most icy or dusty surfaces. In plain words, the light coming off the object looked wrong. This kind of polarization usually means the object's surface has been melted, sintered, or coated with unusual compounds. One theory suggests it may have passed close to another star before entering our solar system, scorching its outer layers into a vitrified shell, essentially turning parts of its surface into glass. Another hypothesis points toward metallic inclusions, like iron or nickel, embedded within silicate grains. If true, that would make 3I/Atlas very different from any known comet or asteroid, and more like an engineered material than a natural one. Alongside the polarization data, spectral analysis from the James Webb Space Telescope revealed something else unusual: an unexpected chemical mix. Typical comets in our solar system release mostly water vapor and a bit of carbon dioxide as they heat up near the sun. But 3I/Atlas showed a surprisingly high concentration of carbon dioxide relative to water, suggesting a composition that's richer in frozen carbon dioxide ices than any local comet. Even stranger, traces of hydroxyl radicals, chemical fragments that form when water molecules are broken apart by sunlight, were detected while the object was still far from the sun, at a distance where water ice should have remained completely stable. That implies the surface was already warm or chemically active before solar heating began. Infrared and ultraviolet spectra also hinted at the presence of iron oxides, silicates, and perchlorate-like compounds, materials typically associated with Martian soil. In fact, when the reflectance curves were compared side by side with samples from Mars's surface, the resemblance was startling. Some researchers have proposed that it might have formed in a planetary system similar to ours, one with a dry, oxidized environment like Mars. Others worry that the similarity could indicate something even stranger. Then there's the matter of the object's trajectory, perhaps the clearest proof of its interstellar nature. All three interstellar visitors so far have followed hyperbolic paths, meaning they aren't bound by the sun's gravity and will eventually leave the solar system entirely. But 3I/ATLAS stands out even here. Its inbound velocity, estimated at over 200,000 miles per hour relative to the sun, is faster than both Oumuamua and Borisov, and its entry angle is unusually shallow, almost aligned with the plane of the solar system's planetary orbits. That's odd, because most interstellar objects approach from random directions, reflecting the chaos of galactic motion. The fact that this one entered along a near-harmonic path, slipping almost neatly between the orbits of Earth and Mars, has led to speculation that its trajectory might not be entirely natural. Even if purely coincidental, the precision of that path has unsettled orbital dynamicists. When plotted backward, its vector traces to a region of the Milky Way near the constellation Lyra, not far from the direction Oumuamua also came from. That overlap could be a coincidence, or it could suggest a shared galactic stream, a flow of material or debris passing through our neighborhood. But the most baffling part is its mass and inertia estimates. Based on brightness and reflectivity, 3I/Atlas appears smaller than Borisov, yet much denser, implying an internal structure that resists deflection even during solar storms. When a burst of solar wind struck its path in early observation runs, most comets would have shown a measurable push, but this object barely moved. Its motion remained perfectly steady, as though it had its own internal stability or mass distribution we don't yet understand. Taken together, all these independent observations, from Mars, from orbiters, and from Earth, paint a picture of an object that refuses to behave like anything familiar. Its light scatters differently, its composition doesn't match standard cometary chemistry, and its trajectory defies simple gravitational modeling. every instrument suggests that 3I/ATLAS is something far stranger, far tougher, and far more mysterious. Now, we'll explore why some scientists quietly admit that this might not be a comet at all, but something entirely different traveling between the stars. Breaking the laws of physics. The behavior of 3I/Atlas defies easy understanding, but researchers have proposed a number of explanations for this that range from the highly technical to the deeply unsettling. Could there be a natural way to explain every anomaly? Or are we seeing something that doesn't quite belong in the category of natural at all? The most widely discussed natural explanation is what's now being called the planetary fragment hypothesis. According to this idea, 3I/ATLAS could be a fragment ejected from the surface of a rocky planet, blasted into interstellar space by a catastrophic event such as a massive asteroid impact or even a stellar outburst. In those conditions, chunks of crustal material can be hurled beyond a star's gravitational reach, traveling for millions of years until they drift into another system. This could explain why the object shows a dense internal structure, minimal outgassing, and Mars-like mineral signatures such as iron oxides and silicate dust. Scientists have long theorized that interstellar impacts could scatter planetary debris throughout the galaxy, but until now, no one had ever found evidence of it. If this theory holds true, then 3I/ATLAS might be the first confirmed piece of another world, a shard of an alien planet that survived cosmic travel to reach our solar system. Another possibility focuses on the object's extreme optical polarization. Some researchers suggest that new, exotic forms of mineral aggregation or dust physics might explain the inverted phase curves observed in its light. In simple terms, it could mean that the fine particles covering its surface behave differently from anything we've modeled so far. For example, if the dust grains have irregular or metallic cores surrounded by glassy mantles, the reflected light could flip its polarization in unexpected ways. This would make 3I/ATLAS a kind of natural physics experiment, a messenger from a different region of the galaxy where dust formation works under slightly different rules. However, each of these natural models faces serious challenges. The planetary fragment theory struggles with the object's cohesion and mass estimates. If 3I/Atlas is a loose cluster of rock and dust, it shouldn't be able to survive interstellar impacts and solar heating without breaking apart. Yet its structure appears incredibly stable. And then there's the tail, or rather the direction of it. Instead of trailing away from the sun as solar radiation would normally dictate, faint emissions from the object appear to point slightly sunward, as though the expelled material were under active control or driven by internal forces. No natural comet or asteroid has ever displayed that behavior. These contradictions make scientists uneasy because the more they refine their models, the less sense the data seems to make. This is where the conversation starts to edge into territory that even experienced astronomers hesitate to enter. The possibility that what we're observing might not be entirely natural. Public speculation exploded after amateur analysts noticed that the object's emissions and reflections seem to pulse at regular intervals. In some reprocessed frames, the brightness pattern looks almost rhythmic, as if there were a stable axis of rotation or even a directed beam of some kind. Could it be an engineered probe, a lost fragment of an ancient structure, or even a lost piece of interstellar technology? Then came the event that deepened the mystery even further, the solar interaction known as the CME paradox. During a major coronal mass ejection on August 29th, the object's brightness suddenly spiked across multiple wavelengths. At first, this was interpreted as sunlight scattering off charged dust, but within hours the object vanished from optical view. It didn't change direction or speed, it simply disappeared. Normally, a CME would push a lightweight comet off course, but when trajectory data from Mars and Earth were cross-checked, 3I/ATLAS hadn't budged even a fraction of a degree. That suggests a mass far higher than expected, dense enough to shrug off the electromagnetic blast entirely. What's more, a single polarized light echo was detected minutes after it faded, hinting that something was still there, reflecting light in a narrow band. Was it vaporized, cloaked in a plasma sheath, or did it activate some self-shielding mechanism we don't yet understand? The data are sparse, but the implications are unnerving. NASA's Jet Propulsion Laboratory issued a brief statement noting that all data related to the Mars rover images and subsequent tracking were under review for calibration inconsistencies. Within 24 hours, several image sets were removed from public archives, with only processed composites remaining available. Insiders reported that the delay was due to synchronization issues between rover sensors and orbital timestamps, but others saw the silence as deliberate caution. In reality, when an anomaly this large appears, every agency involved must triple-check their instruments before releasing conclusions, because even the smallest error could rewrite major sections of astrophysics. Still, to the public, the sudden quiet felt suspicious. Forums filled with speculation about a data embargo or hidden findings. Meanwhile, scientists within NASA, the European Space Agency, and several universities quietly began peer review under confidentiality agreements, waiting for independent replication before saying anything definitive. What makes this so terrifying isn't just the mystery of the object itself, but the fact that no one seems entirely sure how to classify it. If it's a planetary shard, it tells us that violent cosmic events can scatter the building blocks of life across the stars. If it's something engineered, it means we're not alone, and we've just caught a glimpse of technology millions of years beyond our own. Either way, the truth will demand patience, replication, and the courage to follow the evidence wherever it leads. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.